Bismillahirrahmanirrahim. Today we discuss half angle and double angle identities. Since we know that cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. In particular, if beta is equal to alpha, then cos of alpha plus alpha will becomes cos alpha minus sin alpha sin alpha. Cos of alpha plus 2 alpha plus alpha 2 alpha is equal to cos alpha multiplied by cos alpha cos square alpha minus sin multiplied by sin square alpha. So we have double angle identities in term of cos function. Cos 2 alpha is equal to cos square alpha minus sin square alpha. We also know that cos square alpha is equal to 1 minus sin square alpha minus sin square alpha. It will become 1 minus 2 sin square alpha, which is equal to cos 2 alpha. So we have another double angle identity of cos function. We also know that sin square alpha, here we substitute cos sin square alpha is equal to 1 minus cos square alpha. So we have cos 2 alpha is equal to cos square alpha minus sin square alpha is equal to 1 minus cos square alpha, and we have cos square alpha minus 1 plus cos square alpha, which is equal to 2 cos square alpha minus 1 cos 2 alpha. We have another formula for cos 2 alpha. So we remember cos 2 alpha is equal to cos square alpha minus sin square alpha, or cos 2 alpha is equal to 1 minus 2 sin square alpha, or cos 2 alpha is equal to 2 cos square alpha minus 1. Similarly, if we put beta is equal to alpha, sin alpha plus alpha is equal to sin alpha cos alpha plus cos alpha sin alpha. So we have sin 2 alpha is equal to sin alpha cos alpha plus sin alpha cos alpha 2 sin alpha cos alpha. Now we start the solution. Since sin alpha is equal to 12 over 13 and 0 is less than alpha is less than pi by 2, this implies that alpha lies in first quadrant. We know that in a right triangle, sin alpha is equal to perpendicular over hypotenuse. This implies that P is equal to 12 and H is equal to 13. By using Pythagoras theorem, H square is equal to P square plus B square. 13 square of 13, 169 is equal to 144 plus B square. 169 minus 144 is equal to B square, and 169 minus 144 equal to 25 is equal to B square. Taking square root on both sides, we have B square is equal to 25. Taking square root on both sides, B is equal to 5. Now we find cos alpha is equal to base over hypotenuse, which is equal to 5 over 13. Since we have to find this first of all sine 2 alpha, and we know that double angle identity sine 2 alpha is equal to 2 sine alpha cos alpha. Putting the values of sine alpha and cos alpha, we have sine alpha is equal to 12 over 13 and cos alpha is equal to 5 over 13. After multiplying these numbers, we have 5 multiplied by 12 equal to 60 and 60 multiplied by 2 120 over 13 multiplied by 13 169, which is required value of sine 2 alpha. Now we use a double angle identity. Cos 2 alpha is equal to cos square alpha minus sine square alpha. Putting the value of cos alpha 5 over 13 and square of 5 over 13 will becomes 25 over 169 minus sine alpha is equal to 12 over 13. The sine square alpha will become 144 over 169. LCM of both fractions is 169 and 25 minus 144 will becomes minus 119 over 169. So we have sine cos 2 alpha equal to minus 119 over 169. You can write tan 2 alpha is equal to sine 2 alpha over cos 2 alpha is equal to value of sine 2 alpha is 120 over 169 and value of cos 2 alpha is minus 119 over 169. 169, the numerator and denominator cancel each other, so we have minus 120 over 119. Tan 2 alpha is equal to minus 120 over 119. Since tan alpha is equal to 2, it can be written as 2 over 1. We know that tan alpha is equal to perpendicular over base in a right triangle. So we have P is equal to 2 and P is equal to 1. By Pythagorean theorem, h square is equal to p square plus b square, which it will become 4 plus 1 is equal to 5. H square is equal to 5, taking square root on both sides, then h will be equal to square root 5. Now we use the formula sine alpha is equal to perpendicular over hypotenuse. It will become 2 over square root 5, and cos alpha is base over hypotenuse. It will become 1 over square root 5. Now we use double angle identity. Sine 2 alpha is equal to 2 sine alpha cos alpha. 2 sine alpha, value of sine alpha is equal to 2 over square root 5. Value of cos 2 alpha 1 over square root 5. 2 2's are 4, 4 1's are 4, and square root 5 multiplied by square root 5, it becomes square root 25, which is equal to 4 over 5. Now use cos 2 alpha is equal to cos square alpha minus sine square alpha. We know that cos alpha 1 over square root 5, cos square alpha is equal to 1 over 5 minus sine square alpha will become 4 over 5. Taking LCM 5 and 1 minus 4 is equal to minus 3. Sine tan 2 alpha, we know that tan 2 alpha is equal to sine 2 alpha over cos 2 alpha. Value of sine 2 alpha is 4 over 5 and cos 2 alpha minus 3 over 5. 5 is cancelled out by plus 5, and we have tan 2 alpha is equal to minus 4 over 3. Question number 2. Show that cot alpha minus tan alpha is equal to 2 cot 2 alpha. Now we start the solution. Cot alpha minus tan alpha. It can be written as cos alpha over sin alpha minus sin alpha over cos alpha. Taking LCM, sin alpha cos alpha. Cos multiplied by cos square alpha minus sin multiplied by sin square alpha. Now we use a double angle identities. We know that cos square alpha minus sin square alpha is equal to cos 2 alpha. And while in the denominator, a formula will be completed if sin alpha cos alpha multiplied by 2. So we can multiply and divide it by 2. So we have 2 cos 2 alpha, and we know that 2 sin alpha cos alpha is equal to sin 2 alpha. 2 or cos 2 alpha over sin 2 alpha is equal to cot 2 alpha, which is required right hand side. Sin 2 alpha over 1 plus cos 2 alpha is equal to tan alpha. Here we change double angle into single angle. Taking left hand side, sin 2 alpha over 1 plus cos 2 alpha. We know that sin 2 alpha is equal to 2 sin alpha cos alpha, and we also know that 1 plus cos 1 we can add it is, and cos 2 alpha is equal to 2 cos square alpha minus 1. We know that cos 2 alpha is equal to 2 cos square alpha minus 1. Plus 1 and minus 1 are cancelled each other. We have 2 sin alpha cos alpha over 2 cos square alpha. 2 and 2 are cancelled each other, and cos alpha is cancelled by cos square. So we have sin alpha over cos alpha, which is equal to tan alpha. It is required right hand side.